Welcome all. Myself Jishayas, M3SCCM, Department of Civil Engineering, SNIT, Ado. The next topic is bearing capacity considerations for retaining wall. First, what is retaining wall? Retaining wall is a structure used to retain earth or water or other materials such as coal, ore, etc., where the conditions do not permit the mass to assume its natural slope. The retaining material is usually termed as backfill. The main function is retaining wall is to stabilize hillside and control erosion. When roadway construction is necessary over rugged terrain with a steep slope, retaining walls can help to reduce the grades of roads and the land alongside the roads. Cantilever retaining wall bearing pressure calculation. A retaining wall is a structure exposed to lateral pressure from the retained soil plus any other surcharges and external loads. All overall stability failures modes must be thoroughly checked, including the bearing capacity of the supporting. In addition to the retained backfill, retaining walls may be subject to surcharge loads at the top of retained mass. A surcharge may be a strip load. The stem may also have concentrated loads at the top. When the stem extends above backfill, the retained wall may be exposed to wind load. When retaining walls are located in seismic zones, the seismic effects are also considered. Each applied load has a particular effect on the wall. As an example, the backfill exerts a triangular lateral pressure calculated as per the corresponding earth pressure theory. A surcharge produces a uniform rectangular pressure on the wall. The seismic pressure is trapezoidal with higher pressures at the top. This is the typical loads on the retaining wall, such as surcharge, backfill, water table, seismic loads, and wind pressures. Retaining walls calculation of soil bearing pressure. The horizontal pressure on the backfill side will produce an overturning moment with respect to the base of the footing. The overturning moment must be resisted by an opposite resisting moment produced by the vertical forces, including the wall self-weight and weight of the backfill over the heel. Next one is bearing capacity considerations. The first calculate the line of action of the resultant force from the center of the base. We have an equation for x bar equal to sigma mr minus sigma mo by sigma vertical force. Sigma mr is resisting moment and mo is overturning moment. Therefore, E equal to E is eccentricity is b by 2 minus x bar, which is always less than or equal to b by 6. The pressure at the toe of the wall must not exceed the allowable bearing capacity of the soil. The pressure at the base is assumed to be linear. The maximum pressure at the toe and minimum at the heel is given by P max is sigma vertical by B into 1 plus 6E by B, and P minimum is sigma vertical by B into 1 minus 6E by B. The Pmax should be less than the safe bearing capacity of the soil, and Pmax should not be tensile in any case. Tension is not desirable. The tensile strength of the soil is very small and the tensile crack would develop. The effect base area is reduced. Factor of safety for bearing capacity is always equal to Q allowable by Pmax, which is always greater than or equal to 2.5. Thank you.